Clara and 3 friends were all born on March 11th. Already something that you know happens to you all the time. You run into 4 people all the same birthday, right? Leslie is 5 years younger than Clara. Mike is 2 years younger than Clara. Thomas is 3 years older than Clara. And instead of knowing how old they are, or asking, how old are you? You somehow know that on March 11th, 2011, the product of their ages is 61,136 greater than the sum of their ages. This is very practical, real-life example at this moment. This is a great example of someone making a word problem just for you to do math, but actually has no real-life application whatsoever. Because if you were with these people and you wanted to know their ages, you would probably ask them. And if they didn't tell you, for sure they're not going to tell you, oh, I'm not going to tell you, but if you want, we're all born on the same day, and the product of our ages is 61,136 greater than the sum of our ages, because that's exactly what would come to their mind at that moment. But what this question does, as a real-life problem, you will get actual real-life problems that you have to interpret and turn into algebra to solve. And that's really the only purpose of this question. Can we turn this into algebra and solve it? And how would we go about doing it? So, first of all, when you turn something into algebra, you need to introduce a variable and write everything with that variable. In this case, everybody is compared to Clara, or Clara. I don't even know how to say her name. And so I'm going to say, let x equal Clara's age. Clara's age. Oh my goodness. I'm going to call her Clara for short. So we know Clara is x. Then Leslie, who is 5 years younger, would be x minus 5. Mike is 2 years younger, x minus 2. And Thomas is 3 years older, x plus 3. So we've introduced a variable, and we've talked about all 4 people in regards to that variable. Next, they give us a sentence that should allow us to create an equation. The product of their ages is 61,136 greater than the sum. So really the equation, you are comparing the product on one side and the sum, the sum on the other side. I'm going to put those in brackets, but they're not equal. Which one's bigger? The product is bigger. So if I wanted to make them equal, I have to figure out where am I going to put that 61,136. I would have to add it to this side. And we've written out the equation in words so that it makes sense to us. And now we can write out the equation in algebra. So how do I write the product? Product is multiplying. So that would be x times x minus 5 times x minus 2 times x plus 3 equals. Sum. How would I write the sum? I'd have to add them all up. Can you see if you added up the x's, you would get 4x. If you added up the numbers, minus 7 plus 3, minus 4. And then we still have this 61136. If you multiply this out, you are going to get an x to the 4 equation. Okay? And you are going to get a very big number with your x to the 4 equation, which will make it very difficult to factor. The expectation on this question is to either use Desmos or a graphing calculator to solve it. And what we're going to do as a new technique is we are going to put this equation on the graphing calculator into one and this side into the other. Same thing in Desmos, you're just going to write two graphs, one with the left and one with the right. If you do that, it's going to look like this. Back to my y equals, clear this out. The one side was x times x minus 2, x minus 5, and x plus 3. Is that right? Good. And the other side, y2, you could either put the minus 4 and this together and just write 4x. Oh no. 4x plus 61132. But if you wrote 4x minus 4 plus 61136, it'll figure that out for you as well. It won't make a difference. Now, when I hit graph, probably nothing's going to show up. Oh, a little bit of that graph, but nothing of my other graph. So I saw a little bit of the first graph. What do I know about this graph? It would have x-intercepts at 0, 2, 5, and negative 3. It's a positive x to the 4 graph, so it should end up here. I guess over here it probably went up again. What about the right-hand side? The right-hand side, 4x plus 61132. Can you see that that's a line, y equals mx plus b? Can you see that the y-intercept is 61,132? Are you surprised by your graph only going up to maybe 10 that you don't see 61,132? What we need to see in order to solve this is we need to see the two graphs cross. So in Desmos, you might try to zoom out until you can see both of them. On the graphing calculator, if you went to the zoom button, sometimes people like to try, there's a zoom fit, which says, can you fit everything on your graph? Does that help? Oh, almost. Can you see, I now can see the red graph and the blue graph, but they don't cross here yet. So again, the window might be the thing that's most helpful. What does X stand for? It stands for Clara's age. So I'm going to put up to 100, because I'm going to guess she's somewhere in between -1 and 100. Hopefully. Okay? For my Y-min, my red graph was right at the top there, so maybe I want to even go up higher to 70,000. And now my two graphs cross. So your graphing calculator, with Desmos, I think you just click on where they cross, it figures it out. Okay? On the graphing calculator, you have to go second, calculate, number 5. Where do they intersect? Push enter on the first curve, push enter on the second curve, push enter to guess, and x is equal to 17. And this is all work you'd have to show on a test. You plug one into one equation, and you got the answer from Desmos, or you got the answer from your calculator. That's all the work you would need to show. Read the question again. How old was Clara and each friend? So we have it 17, 12, 15, and 20. We've now answered all of their ages. So, not a realistic question as far as something you would actually try to solve. However, a good question for practicing stuff with technology and solving equations. questions for practice right now. I'd like you to circle all the questions from number 3 to 10. So some of them are for question 1, some of them are for question 2.